Chapter 7, Objectives. Identify the solute and solvent in a solution. Describe hydrogen bonding in water. Describe the formation of a solution. Identify solutes as electrolytes or non-electrolytes. Define solubility. Distinguish between an unsaturated and a saturated solution. Identify a salt as soluble or insoluble. Calculate the concentration of a solute in solution. Use concentration to calculate the amount of solute or solution. Describe the dilution of a solution. That almost rhymes. Calculate the new concentration or volume of a diluted solution. Identify a mixture as a solution, a colloid, or a suspension. Describe how the number of particles in a solution affects the freezing point, boiling point, and osmotic pressure of a solution. Section 7.1, Solutions. On solutions, we need to identify the things we put together. So the two terms would be solute and solvent. As we look over here at this picture, we see salt coming into water. So solutions are homogeneous mixtures of two or more substances. And they have two components, the solvent, which is present in a much larger amount, and the solute present in a smaller amount. So over here, our salt is a much smaller amount than the water. So the salt is called the solute in this case, and the water is the solvent. So if one of the substances is water, water is always considered the solvent, even if it is in smaller amounts. So in chemistry, we consider that. In the sapling homework, please just pick the one that's a smaller amount. You are going to put as the solute. The item that's the larger amount is the solvent. Solutes spread evenly through the solution. They can't be separated by filtration, but they can be separated by evaporation. They are not visible but can give a color to the solution. So if you dissolve some copper 2 sulfate in water, the different ions are going to separate, and actually it turns the water blue. Types of solutes and solvents. There are a variety of different solutes that are dissolved in solvents. Quite often, we think of these as liquid items, and they can be different solutions. Now, a solution is when you put a solute and a solvent together, that combination is called a solution. And so you have different examples of solutions. Air is an example of a gas solution. And then in liquid solutions that we think a lot about, think about your soda pop. There's actually gas that makes the carbonation. That is called the solute, okay? And then the solvent, is the water. We can have liquid in the liquid. We can have solid in the liquid. So going back to a soda pop, you put some sugar. They put sugar in your water, and the sugar is the solute. The water, again, is the solvent. Learning check. Identify the solute in each of the following solutions. All right? Press pause and come back and do this. So on A, 2 grams of sugar to 100 milliliters of water. Well, we know that a milliliter of water is 1 gram of water. We learned that some time ago in density. So first of all, 2 reasons we know that sugar is the solute is because it's in less mass, but we also know that if water is one of your options, it's always considered the solvent. B, the one in smaller amount is the 30 milliliters of methyl alcohol. C, the one in smaller amount is the 1.5 grams of NaCl. D, the one in smaller amount is the 200 milliliters of O2. Water as the solvent. It's considered one of the most common solvents in nature, and some books call it the universal solvent. It is a polar molecule due to the polar oxygen to hydrogen bonds. Remember that polar refers to acting partially charged. Notice how the partially charged negative oxygen of one molecule is attracted to the partially charged hydrogen of the other molecule. So when we look at our picture of water and we wonder, why when you spill that water, you don't just spill one molecule, they all are attracted together. Well, it's because of the hydrogen bonding here. And the hydrogen bonding does not refer to the oxygen-hydrogen bond within the molecule of water, but rather the attraction between one molecule of water and another one. Why? Because our oxygen is partially negative. A hydrogen of another water molecule is partially positive. So the negative and the positive are going to attract. And because water has every single side of water has the partial positive or partial negative charge, then you're going to have this attraction on every end of water molecule. Molecules form hydrogen bonds important in many biological compounds. Why? Well, your body is a huge percent water. Hydrogen bonding. What is this very important kind of attraction in biological compounds called hydrogen bonding? Well, if you remember, hydrogen bonding exists between molecules only when hydrogen is attached to either oxygen, nitrogen, or fluorine atoms. Notice in the slide that the partially negative oxygen from one molecule is attracted to the partially positive hydrogen in the other molecule. That is what the hydrogen bonding is. It's this attraction between the molecules. So let's look at solutions with ionic and polar solutes. So let's see why the last two slides just stressed the attraction of water of the partially positive to the partially negative or vice versa. Well, sodium chloride is an ionic compound. Ionic means that you have a positive cation and a negative anion. Cations are positive and anions are negative. So we now have this positive sodium and a negative chloride ion. Well, water can easily and readily be attracted to both of those ions. Why? Because water has this very partially negative charged oxygen that can be attracted to the sodium positive, and so it can be surrounded with all of these water molecules with their partial negative charges, which can help to attract this positive sodium. And not to be left out, the chloride ion, which is negative, also has this major attraction to the partially positive charges of water, which are the partially positive hydrogens there. So that's totally surrounded. Water molecules surround each ion and pull it into solution, separates those ionic compounds into their separate ions because of the attraction. Well, if you don't have the attraction, the salt can't separate. So, if you had a non-polar solute, then you're going to require a non-polar solvent in order to have it dissolve. So you'll notice here solutions that would form. If something was polar or ionic, it would dissolve, form a solution in a polar solvent, i.e. like water. But let's take that same solute. So let's say the solute was salt. Let's take that same salt and see if it will form a solution, i.e. dissolve, in a solvent that's nonpolar. So feel free, go get some vegetable oil, which is nonpolar. It's only got carbons and hydrogens for the most part. It is nonpolar. Put some salt in there, just a little tiny few crystals, and you will see even if a tiny few crystals will dissolve. And that answer is no. Why? Because the solvent is not polar. There is nothing to attract the positive sodium to the negative chloride. So if there's nothing to attract them, they're going to just stay clumped together. And then you go, well, will nothing dissolve in a non-polar solvent? Oh, no. A non-polar solute would dissolve in a non-polar solvent. So you'll notice there that there's this commonality. And the generalization that works a lot, and in this class is going to work like almost all the time, is the term like dissolves like. Polarity of a solute and solvent must be similar in order for them to dissolve. So, if something is charged, it'll dissolve in something that's polar. If something is not charged, it's going to dissolve in something that's non-polar. Ionic salts, They act charged in polar liquids. They act partially charged, dissolve better in polar liquids than nonpolar. Hence, like dissolves like. In salad dressing, salt dissolves into the water and the vinegar in the salad dressing. But the nonpolar, non-charged liquids dissolve better in other nonpolar, i.e. non-charged liquids, than in the polar liquids. So in the salad dressing, the organic flavors dissolve into the salad oil. So a good salad dressing has both oil and vinegar, so both the salt dissolves as do the flavors. So let's look at this. Press pause and see if you can answer this. Solid lithium chloride is added to water. It dissolves because, well, lithium's a metal, and so our chloride ion is a nonmetal. It is an ionic compound. So why does it dissolve? Because the lithium plus is going to be attracted to the part of the water that's negative, and that's our oxygen. The oxygen atom of the partially negative of water. So that's number one. B, the chloride ions, the negative, are attracted to, well, we know the negative is going to attract it to something positive, so it'll be attracted to the hydrogen atom of water.